In homework 6.2, we're learning how to solve radical equations. I'm going to walk you through a few different types. The main idea is that in radical equations, if there's only one variable, or even if there's more than one, our first step is going to be to try to get the radical. A radical is a square root symbol. It could also be different types of roots. We're trying to get the radical isolated. And so, for instance, in number 2, that involves starting by subtracting 9 on both sides to get the radical by itself. As soon as you have the radical by itself, what you can do is we can use inverse operations to square both sides. And because you have to square the whole side, we want to get the radical by itself before we do this. But once we do, it turns into a different type of equation, usually either a linear equation or a quadratic equation. And from here, you're just going to solve as you would any linear equation. Here, p is getting divided by 6, so we multiply by 6 to cancel out dividing. There is one special thing about radical equations, which is that at the end of them, we need to check our answer and make sure it works. There's a thing in radical equations called extraneous solutions, where you can do every step right, and then at the end, if you don't check your answer still might not work. So let's check it. The way we check is we check by, this is our answer. We'll cross it off if it's wrong, but we're going to check by putting in p equals 96 to see, does it make this equation true? Because that's what we're doing when we're solving an equation, is we're trying to see, did we find a value that makes the equation true? And 96 divided by 6 is 16. The square root of 16 is 4. And 9 plus 4 is 13. And so it works. So this is our answer. We got it right. It's a good idea to check any solution of any type of equation, but you have to in radical equations because you can do everything right and it still won't work. Notice here there's two radicals. They're both isolated, so we can just square both sides and it will cancel out the radicals on both sides. And we can solve this linear equation and get x plus 5 equals 1. And so x equals negative 4 when we subtract 5 on both sides. Subtract 5 on both sides. Again, we have to check our answers. When we check, we get square root of 3 times negative 4 is negative 12. 2 times negative 4 is negative 8. And it looks like these two equations are the same. However, the square root of a negative number is imaginary. And when we solve radical equations, we're really trying to solve a real valued expression. And we would say this is an undefined value, at least on the reals. And when we get an undefined value in our solution, this is an example of one type of solution that didn't work. Even though it looks like it makes both sides equal, neither side is defined. And so x equals negative 4 will not make a true equation because you'll get undefined equals undefined, which is not something we want. And so x equals negative 4 is not a solution. And because our only solution was not correct, we say there are no solutions here. In radical equations, sometimes we'll find there's 0 solutions, 1 solution, 2 solutions, even 4 solutions. And we'll check that out later. Let's look at this one. Here we have a radical getting multiplied by 2. And so we're going to get the radical by itself first. We're going to divide by 2. This is a binomial on the other side, so both of them will get divided by 2. And this is where that squaring binomial homework comes into play very nicely. When we square the right side, it's going to cancel out the square root, but the left side is a binomial. So we need to put parentheses and square the whole side. And of course, when we square a binomial, the shortcut trick is, well, before I do the shortcut trick, x plus 3 squared means x plus 3 times x plus 3, and we can distribute. But there is a shortcut trick, which is that when you square a binomial, you can always square the first one, multiply these two together, and double it. So x times 3 is 3x, doubled is 6x, and then we square the last one. And here we have a quadratic equation. And for quadratic equations, when there's more than one x, we're going to make it equal to 0. So we're going to subtract x and subtract 59. We're going to do the same thing on this side, 6x minus x, 9 minus 59. And so I'm going to solve this by factoring. X, we need two numbers that multiply to make negative 50 and add to be 5. So x plus 10 times x minus 5 equals 0. And so x will equal negative 10 and x will equal 5. Now, at this point, I need to check both my answers. When I check negative 10, I get 2 times negative 10 is negative 20. Negative 20 plus 6 is negative 14. Here I'm going to get 2 times the square root of negative 10 plus 59 is 49. You can do this in as many steps in your head as you want. You can also write out each step. Square root of 49 is 7. 2 times 7 is 14. And 14 does not equal negative 14. And so x equals negative 10 is what's called an extraneous solution. But unlike last time when we said there were no solutions, there's still another solution to check. So we need to see, does x equals 5 also not work? Or maybe this one will work. Let's check it. 2 times 5 is 10. 10 plus 6 is 16, so I plugged in 5 on the left side. 5 plus 59 is 64. The square root of 64 is 8. 2 times 8 is 16. So 16 equals 16, and so x equals 5 is the solution. X equals negative 10 looked like it was a solution, but it was not. All right. This is the hardest kind, and it's hard because there are 2 square roots, but there's also a separate number. The trick here is to get one of the square roots by themselves, which is already the case. If we had something like square root of 4n minus 3 minus square root of 2n plus 2 equals 1, we would add this to the other side to get one of the square roots by themselves. But once we do have a square root by itself, we need to square both sides. Squaring this side is easy, but this is a binomial. So when we square it, we're going to have a harder time on the right side. This is a binomial, so we're going to use our squaring binomial trick. We square the first one. 1 times 1 is 1. We multiply these two together and then double it. 1 times the square root of 2n plus 2 is the square root of 2n plus 2. Doubled will be 2 square root of 2n plus 2's. Last, we're going to square this one. And when we square this, it'll cancel out the square root and just give me 2n plus 2. Identifying what type of equation this is a square root equation. It's another radical equation, and so we need to get the radical by itself. So we're going to subtract 1 on both sides. We're going to subtract 2n on both sides. We're going to subtract 2 on both sides, and we'll get 2n minus 6 equals 2 square root of 2n plus 2. If you notice the square root is not by itself right now, we can divide both sides by 2. That's great. Sometimes you won't be able to divide evenly, and if you can't divide evenly, it's best just to square both sides as it is and deal with the coefficient in front of the binomial. This is just like the one we did up before. We're going to square both sides. We're going to be careful to square this binomial. And I'm going to let you finish this on your own because we've already done one like this, and I'd like to move on to other types. This one is a absolute value equation inside of a square root equation. The square root is already isolated, so I'm going to square both sides. And we get absolute value of 5x minus 15 equals 25. We need to remember how to solve an absolute value equation. We first isolate the absolute value, and then the idea with an absolute value is going to turn whatever's inside of this positive. So 5x could equal 40 because absolute value of 40 would be 40. But 5x could also equal negative 40 because if 5x is negative 40, we'll get absolute value of negative 40 will be positive 40. So either way, the absolute value will turn it positive. And so here we get x equals 8 or x equals negative 8. And I need to check both these answers. When I put in 8, I get 40. Minus 15 is 25, square root of 25 is 5, and negative 8 will come out the same way. And so this one has 2 solutions that both work. All right, this is a cube root equation, and it's solved exactly the same way. We isolate the cube root, and then once we do that, the inverse of cube root is cubing both sides. Cubing and cube root cancel out. And negative 3 times negative 3 times negative 3. A negative cubed is still a negative because a negative times a negative is a positive, and then times another negative is a negative. And so we get this. We don't actually need to check our answers for cube root equations because there won't be extraneous solutions. For even roots, square roots, fourth roots, sixth roots, we do need to check our answers. Now, it's a good idea to check it. It can check and see if you messed up, but there won't be extraneous solutions. All right, let's do some applications. Here we've got f of x equals this. It asks, what is f of 13? F of 13 means to plug in 13 for x. And so we're not solving here. This is evaluating. We're going to do 13 minus 4 is 9. 2 times the square root of 9. Square root of 9 is 3. 2 times 3 is 6. And so f of 13 is 6. When x is 13, the y value is 6. Notice that's different than where is f of x equal to 6. Here it is not saying plug in 6 for x. It's saying when is this function going to equal 6? And so this is an equation we would have to solve. F of something means plug that in for x. When is f of x equal to something means set up an equation to find when is that x value going to make the equation true. Lastly, we've got at what points will f of x intersect g of x? Well, two functions intersect when they're equal to each other. And so let's look at where the y values are equal. We want to know where g of x, which is 2x minus 8, will equal f of x. And again, we've got a number in front of this, so we can divide by 2. We need to make sure we divide the whole binomial. We're going to square both sides. We're going to be careful to square the binomial. And so we're going to get x squared minus 8x plus 16. We squared the first one, multiplied these together and doubled it, and then squared the last one. And now we've got a quadratic equation, and we're going to make it equal to 0. And I'm going to finish this off because there is one slight difference in this one. I'm factoring what multiplies to make 20 that adds to be negative 9. X is 5 or 4. And when I check them, they both work, which is great. Both of these make the equation true. But it asked at what points will f of x intersect g of x. These are the x values that they intersected, but points are an x and a y. And so when x is 5, I need to do f of 5 or g of 5 because the y values will be the same. When x is 5, the y value will be 2. And I got that by plugging in 5 here. 2 times 5 is 10. Minus 8 is 2, and so the y value of g of x would be 2. If I plugged in 5 here, I would also see that the y value is 2. That's what makes them intersect. And they also intersect when x is 4. And when x is 4, the y value is 0. And so these are the points where they intersect. We want to make sure we read our questions carefully and answer what is asked. If a car is traveling 50 kilometers per hour, what distance would it take for the car to stop? We've got this relationship between the speed of a car and the distance of a car. And in this case, it gives us kilometers per hour. This is a speed. And so we're going to put in 50 for the speed to see what distance we would need to make this true. We're solving for the distance because that's what it's asking for. What distance makes this equation true? That is what solving an equation is. And I'll let you finish that off on your own. Make sure you include units of distance. The last thing is solving by graphing. When we solve by graphing, the idea is we have two equations. And similar to how we solved this equation by finding where they were equal to each other, we can also solve an equation by graphing both sides. We can do y equals this and y equals this, and graph each and see where they intersect. So we're trying to find out what x value makes the two sides equal. The right side is y equals 8, and that's a horizontal line at y equals 8, so I'm going to go ahead and graph that. The left side is a square root equation, and we graphed square roots the day before this. It's shifted left by 2, left by 3, and up by 2, and it's vertically stretched by a factor of 2. So square root of 1 is 1, times 2 is 2. Square root of 1, 2, 3, 4. Square root of 4 is 2, times 2 is 4. And square root of 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. 3 times 2 is 6. And so we can see that these two graphs will intersect each other at the point 6, 8. When we're solving an equation, we're looking for what x makes the two equations true. And the x value is when x is 6. We can check it by solving normally, but I wanted to make sure we're familiar with solving by graphing. It's especially good for doing in a calculator. All right, I hope this helps. Good luck in the rest of your homework. If you did get any help on these problems, you want to go back and make sure you understood them on your own as